Welcome to today's video, where we delve into the fascinating world of histograms. If you've ever wondered how to unravel the secrets hidden in your data's distribution, you're in the right place. This is Histograms Unveiled, Understanding Data Distribution. Before we dive in, let's start with the basics. What exactly is a histogram? In simple terms, a histogram is a visual representation of the distribution of a dataset. It allows us to see the underlying patterns, trends, and characteristics that our data holds. Histograms are particularly useful for visualizing the distribution of data and identifying patterns or trends. By grouping data into intervals, histograms provide a clearer overview of how values are distributed across different ranges. This graphical representation allows you to quickly grasp the central tendency and dispersion of the data, aiding in the identification of outliers or clusters. Additionally, histograms are versatile tools that can be applied to various types of data, ranging from simple numerical values to more complex measurements. The process of creating a histogram begins with selecting an appropriate number of bins, each representing a specific range of values. Careful bin selection is essential for accurately portraying the underlying patterns in the data. Once the bins are defined, the data points are assigned to their respective intervals, and the height of each bar reflects the frequency or count of values within that range. This visual depiction not only facilitates a better understanding of the data's distribution but also allows for easy comparison between different datasets. Moreover, histograms are commonly employed in statistical analysis and data exploration. They serve as powerful tools for making informed decisions and drawing insights from large datasets. Researchers, analysts, and data scientists often leverage histograms to identify trends, assess the shape of distributions, and make data-driven decisions. In essence, creating a histogram is a foundational step in the exploratory data analysis process, enabling a comprehensive and intuitive understanding of the dataset at hand. Now, let's explore some common types of data distributions that histograms can unveil. Whether it's a normal distribution, skewed to the left or right, or even bimodal, histograms give us a visual roadmap to understanding how our data is spread out. Importance of histograms. Histograms play a pivotal role in data analysis, making them indispensable tools across diverse fields. The significance of understanding your data's distribution becomes evident when delving into various aspects of statistical analysis. Firstly, histograms are instrumental in identifying outliers within a dataset. By visually representing the frequency distribution of values, outliers, data points significantly deviating from the norm, stand out conspicuously, aiding in their prompt identification. This is especially crucial in statistical analyses where anomalies can distort the interpretation of results. Furthermore, histograms are invaluable for assessing the normality of a dataset. Normal distribution, or bell-shaped curve, is a common statistical assumption that underpins many analytical techniques. Histograms provide a visual representation of the data's distribution, enabling researchers and statisticians to assess whether it approximates a normal distribution. This assessment is essential in determining the applicability of certain statistical tests and methods, ensuring the robustness and validity of the analysis. Beyond statistics, histograms find widespread application in the realm of science, particularly in the analysis of experimental results. In scientific research, histograms serve as powerful tools for elucidating patterns and trends within experimental data. Researchers can visually inspect the distribution of outcomes, identify the central tendency of the results, and discern variations or clusters. This not only aids in comprehending the inherent variability of experimental data but also contributes to the formulation of meaningful conclusions. In essence, histograms empower professionals across various domains to make informed decisions based on a comprehensive understanding of the distributional characteristics of their data. Whether in statistical analyses, scientific research, or other data-driven fields, histograms provide a visual and analytical foundation for extracting insights, validating assumptions, and ensuring the reliability of conclusions drawn from the data at hand. Practical example. Let's bring theory into practice. Imagine you're analyzing the grades of students in a class. A histogram can quickly reveal whether the grades cluster around a particular range, indicating the overall performance of the class. This insight can guide educators in tailoring their teaching strategies to address specific challenges. Tips for creating and reading histograms. Now that you grasp the importance, let's delve deeper into the art of creating and interpreting histograms effectively. The utilization of histograms as a graphical representation of data distribution is a powerful tool in various fields, from statistics to data analysis, offering insights that can shape decision-making processes. Tip 1. Choose the right number of bins. Selecting an appropriate number of bins is a critical aspect of constructing a meaningful histogram. Bins are essentially the intervals into which the data is divided. Too few bins may oversimplify the data, potentially concealing valuable nuances, while too many bins can lead to a loss of the bigger picture. Striking the right balance in bin selection is fundamental to producing an informative and accurate representation of the underlying data distribution. Tip 2. Labeling and scaling. The clarity of communication in any graphical representation lies in the labeling of axes and the choice of an appropriate scale. Properly labeled axes convey the nature of the data being presented, enabling your audience to understand the context of the histogram. Additionally, selecting a suitable scale is crucial for maintaining accuracy in data representation. Scaling should be chosen thoughtfully to avoid skewing perceptions and ensure that the visual portrayal accurately reflects the underlying numerical values. Tip 3. Be mindful of outliers. Keeping a vigilant eye for outliers is an integral part of interpreting histograms. Outliers are data points that deviate significantly from the majority of the dataset. Histograms, with their visual emphasis on data distribution, are excellent at highlighting these anomalies. Identifying and understanding outliers can provide valuable insights into the peculiarities of the dataset, offering a deeper understanding of the underlying patterns or irregularities that may impact the analysis. In summary, constructing and interpreting histograms involves a combination of thoughtful decisions regarding bin selection, meticulous labeling, and a keen awareness of outliers. When employed effectively, histograms serve as powerful tools for visually conveying the distribution of data, aiding in the exploration and comprehension of complex datasets. Conclusion. And there you have it, histograms unveiled. Armed with this visual tool, you can better understand the distribution of your data and make more informed decisions. If you found this video helpful, don't forget to like, share, and subscribe.